Our group, consisting of myself, Michael Deffinbaugh, Jack Capps, and Eli Herbst, researched the impacts of climate change on the distribution of precipitation. Distribution of precipitation is how much rainfall, hail, or snow an area receives. In the past few decades, there has been noticeable change in distribution of precipitation across the globe. What's going on and why is it a problem? The increased rate of change is causing issues with rainfall predictions and projecting the future weather. It's pretty agreed upon that precipitation extremes have increased in frequency and intensity within the continental United States. What's causing this increased change in precipitation? You guessed it, climate change. Since precipitation is caused by evaporation, and evaporation is caused by heat, and warmer climates have caused change in precipitation in most areas. The increase in temperature across the globe also affects wind, which changes how heat and water are transported, and therefore changing the distribution even more.
The changing distribution of precipitation is definitely an issue that impacts the entire population of the United States. These changes in distribution can be seen across the vast expanse of the U.S. For example, in the northern and southern plains, the Midwest, and the Northeast, there has been a general increase in precipitation, while in the West, Southwest, and Southeast, there has been a general decrease. These changes typically occurring in the fall. Since these changes in distribution are hard to predict, there is really no pattern for how it changes. This fact could potentially wreak havoc on the agriculture industry in the U.S. For the West and the South, areas which are heavy in farming, a general decrease in precipitation would decrease the quality of the crops produced, which would impact hundreds of thousands of people. More specifically looking at snow, overall snowpack and snowfall is projected to decrease largely over the United States. However, extreme snowfall years have seen an increase in the northern U.S. in recent years.
So, as my colleague Jack just said, if we look at the graph on the right, we can see that most of the change in the distribution of precipitation occurs in the fall, while all seasons are still represented. As we can see, the changes are over all of the United States as well as all of the seasons. And these changes are measured in the change from the normal and the amount of inches of precipitation, not measured as an increase or a decrease. So it doesn't matter whether or not it increased or decreased, just the change from the average value. And if we look at the graph on the left, we can see a increase from about the 1960s to today of extreme precipitation events. Scientists have come up with a 5-year reoccurrence interval for these events, meaning that a certain amount of them would be expected to occur within these 5 years, and that's our zero as a baseline. But you can see a steady increasing pattern from about the 60s. Both of these figures come from the Climate Science Special Report, which is a well-known about report in the area of climate change.
So this begs the question, why is this a problem? So for droughts, which is a decrease in precipitation, it drives out animals and humans from the areas that they're affected because you need water to sustain ecosystems. And when there's no precipitation, there's less water, which means that it's harder to live there. As for floods and heavy rains, which are heavy precipitation events, as just like other natural disasters, they can cause damage to property and vehicles and people. They can kill people, which is obviously a huge problem that needs to be addressed, and they destroy industry because they can affect buildings where business is done, which is detrimental to the economy. A couple examples of this occurring across the world. In Australia, there are severe drought conditions more so than there have ever been there. So the people taking statistics are not exactly equipped to monitor and forecast the situation, which is a problem. And in Europe, there is a similar situation to the US where the northern parts are experiencing more precipitation than they normally do when compared to their southern counterparts. And that could cause an increase in heavy precipitation events there, which will be detrimental to that area as well.
And this is the end of our presentation. But if you want more resources on this topic, I would advise you to check out the Climate Science Special Report, NASA's website, and their effects on climate change. And specifically, in the case of Australia, you can look at the University of Newcastle and Australia's report, all of which are displayed here. Thank you very much.